Hey, my name is Aman,
My name is Brian.
and we're co-founding Cronus Labs. Cronus Labs is making LLMs more efficient during training and testing. And we're doing this with a few different techniques that Brian will talk about now.
During LLM training, we apply a set of techniques to our data to make the data compressed, smaller, and overall better for the model and more digestible for the model. And in doing this, what we see is that a model is able to learn much faster and require less data, which means for us that we see lower computational costs and training costs. For language model inference and serving, we reduce our costs by performing a dynamic compression technique that we're building on top of state-of-the-art research that we hope to see between a 2 and 3 times performance increase uh, during serving, and actually seeing that in how many tokens we are able to uh, produce out of the same hardware. I'm going to pass it back to Aman for some of our software-oriented performance increases.
Yeah, so the main software-oriented performance increases comes from how we're actually using the text and how we're compressing it. So when an LLM generates text, it generates a slew of text which maybe answers a question or does something. What we're able to do is compress text, which is unnecessary for an LLM. And in this compression, we're able to get a significant decrease in the actual quantity of tokens, reducing the overall size of the token count while also maintaining the same amount of performance. So, Brian will talk about the exact quantity and amount of uh, the performance that is saved and why this is impactful.
So some of the key metrics that we go by is how much of the model stays performant and how much money we can save using a new technique. What we do is we have this small model form of a generation. We have a larger model come in and edit what the small model had made. Just come in there and edit the key points so that it gets everything correct. During this process, what we see, especially for conversations, is that we see 99.92% uh, of the performance stays with a standard deviation of 0.2%, while our token utilization for this larger model and our overall cost is 80% lower, which is amazing. Now, for coding and other STEM-related problems, this tends to decrease, but we still see between 40 and 60% token reduction and cost reduction for these larger models. And this is because we are able to generate the same quality data, first with a smaller model and then editing with a larger model.
Yeah. And keep this in mind that all of the techniques that we just mentioned are either fully proprietary or using state of the art techniques that already exist and building on top of it with a proprietary model or technique that we've created. Brian will talk about our expectations of uh, our interactions with 1517.
Yeah. But as 1517 Medici uh, recipients, we're grateful for the sort of backing that we've received so far. And we're able to extend a lot of our early research to the state that we are at now, largely because of that. Um, and so with that being said, we're looking to expand even further with VC backing. And we plan to do this by spending a significant amount of money. Specifically, it's between $70,000 and $75,000 on 3 computing nodes so that we can host both for training and for inference. We can expand our user base while also being able to perform more experiments, being able to fine-tune and train more models at a significantly larger size. Um, we are also hoping to deploy between $20 and $25,000 specifically so that we can plug these machines in, because that tends to be a significant amount of cost. Um, Thankfully, I've already been quoted for the servers themselves, um, and I'm awaiting a quote for the server capacity. So we have a plan in place to see this come to action, and we'd really like for you all to join us in our journey. Thank you very much for your time.
Thank you.